Now at this point here, around this point 5, the core, the inert helium ash, cannot support its weight anymore and will collapse. Now the contraction of this core releases energy. It's the release of gravitational binding energy. It increases the luminosity of the star, makes the star expand and redden, which is this cooling track that you see here. But as the hydrogen keeps burning in the shell and depositing helium ash on the core, the shell narrows, getting denser and hotter. As the hydrogen fuel is used, the star gets less luminous, yet the core luminosity expands the outer layers and the temperature falls. A strong temperature gradient eventually causes convection. A strong pressure gradient causes the convection zone to deepen. At this point 6 here, convection has reached deep enough that it dredges up deep photons. Convection is getting all the way almost to the core. It reaches these layers of shell burning, dredging up these photons and carrying them to the surface. And remember, convection is a very fast way to release luminosity. So the star expands and becomes a red giant. So in the red giant phase, there's more fuel than in the main sequence hydrogen burning. You have higher temperatures in the shell, so the burning is more efficient. And there is a lot of more energy that is being produced as a result. The star gets very luminous and swells. You have this deep convective zone that is dredging the photons from the shell burning region and bringing them up to the surface. This red giant phase is this phase in here where the star is climbing what we call here the red giant branch. The red giant phase continues until the star reaches this point 6 here, which is when the star suffers helium flash. To understand the helium flash, let's understand what happens to the inert helium core.